Along the theme of the of feeding the future that we have at IFT, I want to present a topic that's hopefully of good interest to you all. And this is in the area of robotics, as far as food handling and increasing the productivity in our food supply chain. I'm the Vice President of Sales for Soft Robotics out of Boston, Massachusetts. My name is Mike Harper. I've been in the robot industry for well on 30 years now, and have seen the evolution of the industry itself from the very early days to the point where we're at today, with a great increase in hype that we see in the press and in commercials and in our everyday lives that we didn't have just a decade ago. So it's an exciting time to be talking about. It's a very relevant topic for us here. Robotic automation, as we've seen, has made headlines of late. We've heard talk of the excitement about robots making our lives easier. We've heard of angst and frustration about, oh, robots are going to be taking all of our jobs and they're going to be doing everything that people do. There's some fear in not understanding what robotics can do. But I'm here to hopefully allay some of that and to really lay some basic needs down before us and talk about some solutions in robotics that help us to solve some problems that are right on the horizon that we're having to deal with today. The point that I want to make from all of this is that robots are here to stay. The problems that are associated with robots are ours to solve. And so as a company at Soft Robotics, towards the end of this presentation, I'll show you how we're doing that. But before we do that, I'd like to build up a little of the case here for the problem that we're trying to solve. The current robotics industry is a very large one at $40 billion, but it is not, that number is not exactly accurate. This is the robot industry number that's associated with what we think of in traditional industrial robotics. This does not include the commercial or the commercial robots like Roombas and lawnmowers and those kinds of things that, though they're robotic, they're not included in this number. This is the industrial number from the International Federation of Robotics. It sits about $40 billion globally for the market. The things that are excluded that really make this number smaller, though, that make this to be a small number compared to what it should be, is that the large meaningful markets like food and then consumer packaged goods, we'll take a look at that, and then e-commerce and warehousing and that type of stuff is not included here because we're at the very beginning of that emerging adoption of robotics into the market. The existing rigid robotic technology market is not able to deal with the changing demands of the market, and food is the big one here. And so this is where I think we'll find some agreement on what the problem really is. What we'll talk about now are the markets that we're looking to address in terms of solutions that have never been available before. Food is really the big one. Food is a market that is, as we know, and as this is our whole show and our whole conference is built around, is not going away. It is not subject to the ebbs and flows of the automotive market or the computer and semiconductor market and such. It's here to stay. The unique problem with food from a robotic standpoint is that there are no two apples that are the same. There are very delicate products like eggs and bakery items and things like that. There are products that we need to have on a daily basis in very high volume that are just not confining to the way that we like to handle things with robotics. Advanced manufacturing deals with things like consumer packaged goods, things that are irregular shapes. If you think about shampoo bottles and soaps and detergents and things, there's any number of shapes of those things that are on the shelves in the stores, and those things go largely on customer preference or customer useful life. And so they're, by definition, they're going to be as varied as the products themselves. And then in the area of e-commerce, we've seen just an explosion just in the past 3 years and the adoption of the large by the large e-commerce companies and the need to handle more things autonomously, more things automatically. We talk about food to fork, and certainly e-commerce is going to have a place to be in that entire continuum. So today it's done with people. There is no better, really no more adaptable, no better solution for handling these products today than a person is. And I'm not up here to say that robots are a better way to do it. I am up here to say, though, that robots are addressing a need that we're going to define here that that we just unfortunately have run out of ways to handle with people. As produce, and we'll specifically focus on the food market for a few minutes. The data that we have for the produce industry, and looking at the trends back for the past 5 years, shows this 5% annual dollar growth in consumption. And this is a very interesting number in itself. It parallels, population growth and other things it correlates to as well. But if we look at where it's coming from, the 6 of the top fastest growing categories are what's interesting. Value-added vegetables means assortments, mixes, things that don't occur naturally in nature. With the fruits, the cooking greens, especially fruits and fresh produce. This is not even considering things like meal kitting and those types of things that are further enhancement of the variety that we see in food. So we know that produce sales is continuing to rise. We know the need is going to continue to be there. But what we don't have to offset that is enough people to deal with the problem. This is a very interesting graphic that we like to pull up and to show people. If we look at from the data from 1998 up until 2012 by the demographic categories here for field and crop workers, we see that the 45 and above segment of the population is actually a growing percentage of the total field and crop worker population, and the 25 and under component of that is shrinking. So it's very apparent to us and to everyone else that we've got a real problem to deal with. We've had input from a CEO of a major strawberry manufacturer that they've had to abandon a third of their strawberry crop in a recent year due to not being able to have workers to get it out of the field. So the problems that we have as far as handling food are very real. And up until this is last decade, we haven't really had a way to deal with the problem itself. So taking a scientific approach to it and say, okay, what did we do in the past when we had a boom need for more labor? And we go to the automotive industry because it's been really the most sustainable growth in automation that we have, on the planet. And if we go back to 1915 and look at Henry Ford's Model T assembly line, we see a modern looking assembly line, a linear assembly line with cars coming down and people doing the installation of the various components on that car. If we fast forward to this year and we look at the Tesla Model S assembly line, it's still a linear assembly line by stations where various components are being added at each station. But in this case, it's all being done by robots. It's all being done robotically. A couple of reasons for that you can think of in the automotive industry. Well, one would be that parts and component subassemblies are heavier than they used to be back in Henry Ford's early days. And the second reason just is that the quality and safety requirements of today's industrial environment are greatly different than they were back in 1915. So if we look to this model and we project it onto our problem we have with food, strawberry harvesting line at any pick a year, we'll just start with 1915 as we did with Henry Ford, and we fast forward to today. The only difference really is that you see it in color. It's really the same. It's the same methodology that happens in strawberry harvesting that's happened for decades and decades. So this is a real problem for us that we have real solutions for, and I want to delve into it just a little bit on how we can go about doing that in a few slides. I want to add a little bit of detail to the food safety question here. Specific to this conference, the questions of traceability and of food safety and those kind of things are very common. I've talked to several folks at the conference who this is a very important topic. And a couple of very recent examples just to highlight a potential problem that can be solved with the technology we're going to look at would be things like the swine flu outbreak that recently happened in China. And we can, though I don't have the specific numbers for the amount of livestock affected, we can just look at the price of pork futures and see the uptick of when that of when that problem actually happened. And then even in our fast food or our restaurant business, we can see that, and we can all recall of various outbreaks and things that have happened with recalled food, whether it be from the grocery store or whether it be with restaurants having to relook at their processes and systems. So we have a problem of contamination. And contamination, as we know, bacteria, it's going to have to come from some living organism. And in the food handling segment of the supply chain, this comes from people. So in addition to us having a shortage of labor, we have this very real, very difficult to handle situation where people having to touch produce introduces a potential transition of bacteria and illness that can get into the food chain. So we've seen it through examples empirically. We've also been able to study it out in industry in the supply chain and have determined that it's something worth considering. If we're going to consider a solution, why don't we consider a solution that looks at as many of the problems or components of the problem as we can? So we're going to define the problem then in a way that I think makes sense. As largely an academic a group here at the conference, I think it's best to sort of quantify or at least to put into buckets the various things that we're trying to solve, and then we'll talk about how to do it with robotics. So if we determined and seen from the data that labor is increasingly scarce and expensive, we have crops sort of rotting in the field, we have an aging workforce that is starving us for resources to pick and pack. We have some safety and sanitation standards that are getting to be more and more stringent as we go forward, needing real solutions to those that to sort of take people out of the equation. And then we have other things that from year to year are very unpredictable that do affect sort of the productivity of the entire supply chain and ways that we can maybe stabilize that or make it more effective. These are all worthy of putting into our problem statement. So we have a solution then to that. And in business, we know that we've got to have a return on our investment in order for that to make sense. So I'd like to take the viewpoint that what we're going to do is not something that we do just because it's novel or interesting. Certainly, it's fun to sit and watch robots mix drinks at a robotic bar, or to watch a robotic lawnmower cut your grass. I mean, those are entertaining to do. They don't have the same ROI that something as critical as food production might have. So we've got some very real opportunity in terms of return on capital investment in the food supply industry that are right before us. I want to pause for a moment and talk a little bit about the finance part of it. In our industry, and what I deal with on a weekly basis in our industry, is a shift in thinking and investment out there for companies who produce food from the cost of manufacturing tends to have been in not in the capital goods, but rather in the cost of production, the hourly wages of workers, and these variable expenses that can be floated with seasons and can be adjusted with adding or taking away from them themselves. So these variable costs that are up front are going to have to change to fixed capital costs in robotics and other automation and machinery. So there's a transition in thinking that has to happen in the finance office of the food companies. But when we can explain the ongoing benefits, the return on the investment, and the improvement in the overall supply chain, we tend to be very successful in trying to argue the case for the robots. So what is it going to look like if we do this? Well, we've already seen a trend from 2017 to 2018 in a 48% growth in the use of robotics in the food and the consumer goods space. And I think it's the next slide, I'll show you that some of this is just fine. It's been in the more traditional areas where we are trying to replace heavy operations or repetitive tasks with robotics, and that's very good. It helps drive adoption to it. But further to that, we're getting to be more comfortable with robots. If we think about the traditional industries, the automotive industry certainly has saturated and plateaued. It's growing at a negative 12% from 2017 to 2018, based on the cycles of the automotive industry itself. In fact, not really germane to this conversation, but if you think about it, electric vehicles themselves have put a real dent in the traditional automotive manufacturing methodologies, and it's showing up in robot production. Rubber and plastics, life sciences, those are all growth industries as well that are not traditional uses of robotics. We've seen very good success in penetrating some of those new spaces as well. As I talk to folks about robot systems and costs, one of the examples that I use for them is the computer industry, sort of the Moore's Law approach, where robotic systems costs year on year have gone down if you look at it in an overall system investment standpoint, gross dollars, or if you look at it as automation per operation. In the case of food production, is typically cost per pick is what we talk about. Those costs are going down over time, and they're projected to continue to go down over 20% over the next decade. So this is all very good news. If we're talking about a financial justification for solving the real problems that we have in food production, we have to have something that we can look back on and count on. And so fortunately for us, the industries of automotive and semiconductor have provided this ramp and have proven to us that we will actually save money on a use case basis over time. So we talked about the growth in robotics in the food industry, and those are largely coming in the easiest to automate areas, which are things like palletizing. We look at palletizing boxes, or in this case bags of product. It's a very repetitive, ergonomically poor operation that people have traditionally done. And why have they done it? Well, when you palletize product, unless you're making exactly the same product every day, all day, it's very hard to put fixed automation in there to palletize that. If you're changing bag sizes, box sizes, or deliverable SKU lots, you've got to be able to adapt to that. People are the most adaptable way to do that, and that's what we've seen over time. So palletizing has been a very good one. The packaging and the picking and packaging of very repeatable products like cheese or hamburger patties, things like that are really the same every time, has become something that's being embraced by the industry as well. If I can package cheese in a cold room and people don't have to do it, the same thing every day for 40 hours a week, the companies are going to see the payback on that, and we're going to get installations in there that are starting to move that labor into more desirable uses within the organization itself. So the term Delta robots is a robot that is one that's shaped sort of look like an inverted pyramid, and it goes very, very fast. It's got a low mass on the tool and able to move very quickly, very repeatably, and is used in all sorts of applications out in our industry. The environment itself that we're going to now penetrate with robots, in addition to palletizing, in addition to high-speed picking of repeatable products, are things like produce packaging. If you spend any time out in the Central Valley during the harvest, you'll notice that there's lines of people sorting, sizing, packaging, everything from avocados to pecans to apples, and so it's a very labor-intensive process that is very flexible, very adaptable to the size of the harvest and the time needed, but it's yet something that's becoming increasingly more difficult to do. Seafood packaging. This has been one of the areas that our feedback has been people just don't want to do it. If they could do something else, they would rather do it. It's very difficult to spend all day in a cold room packaging seafood every day for very, very little value added. Bakery is a very interesting one as well, and you'll see in a video coming up very shortly that bakery has its own set of challenges, and typically that is that baked goods right out of the oven or even in raw form are very delicate, and traditional robotics and traditional methodologies can't pick them up very well. So it's a product in its primary form that is something that's made to be handled by people, but finding people to do it is very difficult. So we've solved that problem in a number of ways as well. So with that, we'll move on and look at an example of what I'm talking about. So this will be very different than a lot of what you've seen at the show, but this is an approach that's being used out there in industry right now which is called Soft Robotics Solutions. You can turn the volume down. You can turn it down. Yeah. So it does have music, but it's just a music track. So if you take a look at the video, we're packaging eggs. Eggs are something that's very difficult. With this product, are these products that you're seeing, we're locating them with a vision system. We're telling the robot where that product is, what size it is, and what orientation it's in, and we grasp it without damaging it, and we're able to handle it. It's an interesting way to go about solving problems that have been around a long time. And you can imagine if you looked at this in the wild, you would say people are the way to do it. Indeed, they have been the way to do it. So solving these very difficult problems it was the very beginning of our company. We were founded in order to unlock automation technology for all markets, primarily the ones that haven't been addressed with traditional robotic automation. We have a product that gives us hand-like dexterity, as you saw picking up those fruits and parts, based primarily on material technology and not so much on deep learning or artificial intelligent programming, although that does have a place in the industry. And probably further than that, it is made for an industry who's not used to using robotic automation. So it needs to be very robust, needs to be plug and play, easy to implement, and easy to get a return on the investment for. So if you take this combination and you look out there was no solution for it. And it just so happens that back in the 2007, 2009 timeframe, the US government through DARPA had a grant out at the Whitesides Institute from Dr. George Whitesides at Harvard University to solve a problem that they were trying to do in a flexible, adaptable product to be used in military and defense applications. So the Whitesides group tackled that. They were very successful in producing what was called a ChemBot, which is a soft, flexible device that behaves in every sense like a robot without being a rigid product. Fast forward to 2013, as the technology then was released by DARPA and able to be commercialized, the company was founded in 2013 as Soft Robotics, Inc. In July of that year, nearly 6 years ago. It's based on the technical patents that we have, the pending patents that we have, and grants to further develop the technology into an industrial and commercial product. So our company is very young, 6 years old. If we take a look at the first sales in the market were around 2015. We began to grab the interest of journals like the Wall Street Journal, and then various trade industries started looking at it and said, this might actually be a real thing. The robot industry itself sort of held back and says, we don't know. This is not what we've done before. So we're going to have to wait and see. So we trudged ahead, and over the past several years have been very, very successful with the early adopters out there in putting in applications in production today that are running literally billions of cycles combined between them. The adopters tend to be the bigger companies who are more forward thinking, who are being more impacted by the labor and safety problems that are in the industry. And they're the ones who tend to be coming to us and saying, we need a solution to this problem that we haven't been able to do before, and let's go off and do it. Whether it be handling raw pizza dough, or whether it be harvesting lettuce from mobile devices, or handling donuts and putting them in mixed packs, or packaging meal kits and doing the like. There's any number of things that your imagination could come up with that could be done in this fashion, and we've been able to address it. To sort of convey where we are in the adoption of the technology, if you think about automotive technology, anywhere there's an automotive plant in the world, there's going to be a slew of robots in there. It's a very stable market. It's a market that's very accustomed to using robots. In the food industry and the unstructured environments that the soft robotics deals with, we are primarily now installed in the very robot friendly, the very forward thinking markets in the world, which include the US includes Western Europe, and then also includes Asia in the robotic friendly markets there. So what this tells us is that we've got traction in these markets, and we've seen just in the past, I'd say 9 to 12 months, we've seen what we're calling an explosion of sorts out from these robot-centric areas into areas where the plants are, and typically robots haven't been seen for hundreds of miles in some cases. So the adoption is happening. The acceptance of the technology into the industry is becoming more proven with every million cycles that happens. And when companies, the big food producing companies, start to see their financial payback, then they raise the adoption, and we continue to go on. So that's where we've come to when we got to this point where we're being covered now by everybody. Dr. Whitesides actually coined the phrase soft robotics, and I think he owns the trademark itself. But we have our own academic journal that's surrounding soft robotics. Our CEO, Carl Voss, is an active member of the World Economic Forum, as we can see that food production and supply chain is an extremely important subject for the World Economic Forum, and he's helping to drive solutions in that way. We've seen various other academic journals and a lot of industry groups shown great interest in the technology, and you'll hopefully hear more and more about it going forward and start seeing it in more commonplace areas as we're solving the problem. I'm going to show a video now that's just going to loop here, and during this video I want to circle back and make sure that we talk about, there we go. Make sure we talk about the solutions that we're trying to drive for. We're trying to save crops by providing a method to get those crops or that food from its raw or unfinished state into a packaged state. And so that's previously been done by people. We have a definite and documented shortage of labor to be able to do that. So now we're showing how we can do it with robots. Robots, we put a vision system on them. They have full 3D cognition for where parts are, and we can handle things like raw pizza dough. In this video, we can mix various things together, like the stoplight pepper packaging that you see in your grocery stores. We can do proteins, fresh fruits and vegetables, and bakery items sort of all day long. If you're familiar with Peeps, the little mushroom or the marshmallow, not mushroom, the little marshmallow candies that we see, all of the Peeps that are now, for the past 2 years, have been packaged by our technology. So this gives you some idea of how this works. It's not really doing anything different from a robot perspective, but it is doing things that have never been done before from a grasping perspective. That is the enabler that the food industry has lacked to be able to put widespread adoption of robotics into the mainstream for the industry itself. So with that, I'd like to open the floor, and we can run with a mic if we need to. If anybody have any questions for me, I'd be happy to address. If you see anything that's strange or would you like me to answer?
Mike, that's been a fantastic presentation. Thank you. If you have any questions, just raise your hand.
So it tie it to the quality control aspect too, that a human would give you that this wouldn't.
From the human perspective, yes. So even in something as flexible as soft robotics, a great question, because even in something as flexible as we have, you still have to define the part that you're picking up. So, for example, the same tool that we would pick up a watermelon, and we would be, picking up cantaloupes or watermelons, we would not be able to use that exact same tool to pick up pecans. The same person could certainly pack one on one day and the other on another day. So no matter what we've done up to this point, we still haven't maintained or gained the flexibility that a human being actually does have. The other difference is that we have tactile sensation and haptic feedback that we get from our fingers that we haven't built into this simple tool. The tool is set up to grasp at a given grip strength, which the operator would set, and that's what we pick up to. So we can't tell if something slipped out of our grasp, and we can't tell if something is colder than it should be or hotter than it should be, that kind of thing. Those are all certainly possible, but they triple the cost of the investment for automating the same type of thing. So we're not there yet, but we're moving up the curve of replacing a lot of things that people have been doing. So that's interesting. So we would couple that technology. So the question was, if the fruit was damaged, well, we know not to pick it up. So what we would use in that case is the input from the vision system that we've defined. And we said, I talked to a great example. I talked to somebody yesterday about apples, and we talked about how to determine if an apple is bruised or not. And we can do that with a vision system. But in order to do that, you have to teach the vision system what is a bruised apple, how brown is brown, that kind of thing. We have plenty of technology to do it. The bigger question, just like the size of the product, is defining it for the system itself. And so that's where the value of this is actually the biggest value of what people bring to it, is the experience to say that, here's an apple that looks like it's bruised, but it's actually not. This is just a different form of defect. Here's an apple that is bruised and might pass by inspection because somebody doesn't see it based on the sheen on the outside of the apple. So those are great questions that have to be dealt with. And the problems that we haven't solved are in areas where it does take human intuition or the flexibility of what humans bring that robots and vision can't bring to solve the problem. So I don't want to be mistaken to say that we know that robots and vision can replace every operation. That's certainly not it, especially the ones where there's more thought given to what's actually happening in the process. That's great. Automotive dealt with the same thing when they were painting cars. They had this decade-long problem of determining if this paint was right or not, because the automation couldn't tell if the hues were right or if the runs were, if you saw runs and that kind of stuff. And it took a full decade to get past that problem with them. Good question.
Yeah, very good question.